Hi, my name is Daniel and I am test infected. Before working with Moodle, I had some good experience working with MVC frameworks. After getting bitten by TDD many times, I grew stronger, and as any test infected developer, it's now difficult to trust wild code. So guess what happened when I started developing Moodle plugins? I wanted to use a TDD paradigm. So what is TDD? TDD is a mechanism that ensures your project only moves forward. TDD stands for Test-Driven Development. It's a methodology where you write tests before coding a solution. You don't spend too much time planning ahead. Your beautiful design will come up from constant refactoring. In TDD, there is a red-green refactor mantra. First thing, you get a test that is failing, and then you're going to write some ugly, smelly, hacky code to make the test pass. Now that you found a solution, you refactor it into something that you are proud of. With a test ensuring that your solution does not regress, you can restart the cycle. Quick example, we are creating a function to test if a string is palindrome. A very simple and small test is to check if an empty string is palindrome, which should be true. But when you run the tests, it fails because the class myPlugin does not exist. So we are doing TDD styles, so let's focus on the error at hand. You define that class and test again. Now the function isPalindrome does not exist. You define that function and test again. Now the result is not true. You set it to return true and test again, and now it works. The test is green. But sometimes when you're coding your solution, you may start thinking of error paths or some ideas worth implementing. For example, you may want to make that function not case sensitive. A nice touch is to create an skipped test like this, and then you can forget about it and focus only on the error at hand. Now, if you think that the isPalindrome function is incomplete because it's always returning true, well, prove it. Write a test that fails, and now you know what's the next thing to fix. Now remember, the IDE is your friend. They can automate running tests, code stubs, and a lot more. I know that some meta-humans can do everything in Vim, but for the rest of us, there are some very good IDEs around. Regarding tests, there is a great tool called Moodle Plugin CI, which incorporates a whole bunch of useful tests. You can use it to create the base for your plugin from scratch using TDD. Just create an empty directory and start running the tests until they are all green. If your code is on GitHub, then you can automate that with Travis continuous integration. It will run all tests after every push or pull. It's going to allow you to test several environments like different Moodle versions, PHP or database. It is free if your repository is public, and it's easy. You can just use Moodle Plugin CI template for Travis. Now, types of tests. There is no single correct definition here. It's not important what you call it, but what it does. In any case, let's see some of the common definitions. Unit tests ensure that small parts of the code work by itself. You may need to do a lot of mocking in order to isolate the functionality you want to test. In Moodle, we are going to use PHP unit, but it may be difficult to perform some tests as many components and functions cannot be mocked. Integration tests are not testing one single component, but how different components or services work together. There's a little bit less mocking, but still need to mock some components. In Moodle, we are still going to use PHP unit, and we are going to face the same challenges as writing unit tests. Now, functional tests. They ensure that one desired functionality works as expected. We are going to use little or no mocking, but we may want to emulate the environment so tests can run faster. It can be used with legacy code. Most of Moodle tests will fall in this category because they don't need to isolate components, but check what's the result for a given action. Moodle does not adhere to the MVC or Model View Controller setup. So many functional tests are actually written using Behat because they require a web server. If possible, try using PHP Unit. It runs much faster. But if not, then of course feel free to use Behat. Regression tests. A regression test is very important in TDD. When a bug is found, it must be isolated as a test, which is failing because of that bug. When the test gets green, then it means that the original bug has been fixed, and it will prevent the same bug from being reported again in the future. The regression test can be written as any other type of test, depending on how well you can isolate it. A behavior test is very similar to a functional test, but this time we are going to ensure that the system does what the user expects. There is no mocking at this stage because we want to simulate the interaction of the user with the complete system. Now, the interesting thing, if you start your development by writing behavior tests before writing code, then welcome to behavior-driven development, or BDD. In Moodle, we are going to write gherkins and use Behat. We will talk a little bit more about it later, but first let's see acceptance tests, which define what should the system do before it's considered ready. Generally, they are a subset of the behavior tests with a good visibility from the product owner, who is going to review and approve those tests. It can be a great tool at project management level. Now, back to gherkins and BDD, let's write in plain English the use case as a test before we start writing any code. So, given I am on the login page, when I fill my username with Anna and password with Madam, which are both palindromes, and I click the login button, then I should see on my dashboard, then I should be on my dashboard. When you send this back to the client or to the product manager, to the product owner, he's going to say, sorry, I think I expressed myself wrong. I wanted the password to be an anagram of the username, not a palindrome. Now, we rewrite the scenario and this one gets approved. We just saved possibly 1 day of work by not going on the wrong path. But now, let's run those tests. We're going to use Behat, Selenium, and Docker. Behat is going to parse the gherkins language so it knows what needs to be done. You're going to need something called context definitions, which maps the statement in plain English into a PHP function, which will make calls to Selenium driver, which is in its turn opens a web browser and performs the required actions. You can run it on your machine, but you're going to see something like the browser opening and things happening like magic, but the alternative here is to use Docker, so it runs in a VM away from your real browser. Don't worry, you can still remote access and see everything that's happening there. So, if TDD and BDD are so great, why isn't everybody using it? The biggest problem here is legacy untestable code. Moodle is not test-driven. While in newer frameworks not using TDD could even be considered a technical debt, Moodle is not a new framework. Its first version came even before PHP Unit 2 existed. With that, we have the problem with the learning curve, which will slow down your development at first until you start finding your way around. If you lack on experience with TDD, you may end up with many false failures due to bad tests. And it's also difficult to do it if other team members don't follow TDD. It's going to introduce untested and untestable code. Now, some people also prefer using code coverage. Code coverage analyzes during the tests which lines of code were actually tested. It's a great tool, but it's not used for TDD. It tells us which lines the test case covered, but it can be very misleading in terms of what is being tested. Talking about untestable code, the thing that annoys me most is finding static variables inside function. In this case, the user variable is going to be stuck with its cached version the first time the test runs. There is no chance to change it afterwards. It would be better to have it defined as a field in a class instead. What about a case like this? This function depends on another class, TDD User API. Imagine that when you run it, it is going to connect to a remote web server, which you don't want to, or may not even be available at test time. This is a typical case where it would be better to have dependency injection. Some developers consider deterministic static methods to be okay, while others do not. A deterministic method means that regardless of the environment or internal state, it will always return the same result given for a given input or parameters. Static methods are very difficult to mock, so it could be a problem. For example, if the code depends on them, but if they are self-contained as most likely a utility function, it may not pose a problem during tests. That's your call. Now, with non-deterministic static methods, the problem grows bigger. Imagine that getUser is an expensive call, potentially using an external service, and if I were to test the validate method in TDD auth, how can I mock the result of getTDDUser if it's a static method? My suggestion is to avoid static methods most of the times, and if using them, make sure they are deterministic. Tests with time are very difficult to write. For example, these two calls would happen so fast that the times would be the same. If you cannot use dependency injection, you could at least make the time an optional parameter. If not given, then use current time. Not ideal, but still better than nothing. Functions, non-object oriented, may also be a problem in testing. For example, the redirect function is going to kill or error your tests. If you need to create functions, for example with hooks, you can make it so it just hooks and calls a method of an object. Loose code usually runs in a page script, not meant to be required, but accessed directly from the web. It may be set in headers or redirects, and they are meant to execute from the beginning until its end. This is very hard on test case. If you just try to require that files something in the initialization, or Moodle bootstrapping will make it fail. One solution is to make your pages to use a controller, bootstrap Moodle configuration, then simply create and use a controller object. It may confuse some Moodle developers as this is not the Moodle way, but it makes a lot of sense from TDD perspective, and even more if you used MVC frameworks before. Requires in general are a common part of untestable code. Ideally, you should rely as much as possible in class autoloading, but too bad we cannot rely on that for part of Moodle core functionality. Often, someone who takes TDD to the extreme is called a pragmatic, but this is a misuse of the word. I prefer to use dogmatic instead, as in believing that TDD is undeniably the best approach for every scenario. In Moodle, it's not always possible to write every bit of code in response to a failing test, but trying to do that has some value. It's a great learning experience of Moodle internals and APIs. However, some files may contain metadata such as version, events, or access, or extremely parameterized calls, and they may not benefit so much writing 100% TDD style. In any case, when times allow it, be a little bit dogmatic as an exercise. That's how you're going to learn its deficiencies. Now, pragmatic means dealing with things sensibly and realistically in a way that's based on practical rather than theoretical considerations. That means that a pragmatic developer will know better what and how to test. For example, settings.php may contain several parameters that are best tested through the validation method, but you can still write a unit test to make sure all desired fields are at least defined. Moodle forms are easy. You can just use the mock submit function or just change the get or post superglobals. Unfortunately, headers and redirects, they are basically untestable. It would be good to have something like it's done when debugging is called. It's going to cause a test to fail unless that was intended. But at least writing a test, even if it doesn't write 100, even if it doesn't drive 100% of the generated code, it's still driving most of it, as you are parsing it like in runtime. So it's still going to detect some common issues, like someone deleting a language string. That was a quick overview about TDD in Moodle, and I hope to see more Moodle devs test infected in the near future. Thank you.